Yes, dear students, good morning. Today we are going to see about the unsupervised learning algorithms. Okay, so last two videos we have discussed about what is unsupervised learning, one its definitions and applications, where it is used, as well as the types and categories. So, what are the types and categories we have discussed? That is the clustering and also dimensionality reduction. And clustering, we have three or four types of algorithm. We have it supports the clustering, and especially on dimensionality reduction, we have two supportive algorithms. Okay, in this video, we are going to see in detail one by one. That is, first partitioning, k means clustering. So in the clustering algorithm, the first algorithm, it is k means clustering. Okay, so it is mentioned that partitioning or k means, that means what, the every grouping. Clustering, we know that is the grouping of data. So the grouping will be made in terms of k means, that means this, some partition will be made. Okay, then the shape we can say it is a k type. Okay, it is a type of clustering that divides the data into non-hierarchical groups. So hierarchy means we knew that it is a orderly manner. For example, if we have an education institution or anything else, like if an education institution, the hierarchy is there: chairman, correspondent, and the directors, and the principals and deans. Okay, so the faculty member, HODs, faculty members, and students, and then non-teaching staff. So likewise, we can have some hierarchy. So that is called hierarchy. But in this case, we are not going to follow the hierarchy. That is non-hierarchical groups. Okay, it is also known as the centroid based method. So the other name of non-hierarchy group, we can call it as the centroid based method. Okay, the most common example of partitioning clustering is the k-means clustering algorithm. So here it is named as k-means clustering algorithm. In this type, the data set is divided into set of k groups, where k is used to define the number of predefined groups. That means what? K is used to define the number of predefined groups. Already it is predefined groups is there, and it will we will access using the k. Okay, the cluster center is created in such a way that the distance between the data points of one cluster is minimum as compared to another cluster centroid. Okay, so this is how the clustering of k means it is going to happen. Now we will see the k-means clustering image. So you just look at the image. We can have the category like red color, green color, blue color, and gray color. And also in the red, we are having the shapes of circle, and the green we have the triangle shapes, and also again coming to the blue, we are having the circle, and in the coming to the gray, we are having some square shapes. Okay, so and this is how we are categorized based upon the color, shapes, and we will make in case of it's a k partitioning. So something non-hierarchical partitioning we are making based upon the grouping of data, that is called k means clustering. And coming to the next algorithm, that is what is called distribution model based clustering. So here also we can easily understand that is distribution. So it will be distributed based upon that. And EM, what is EM means? It is expectation maximization algorithm. So how much maximization we can make, how much expectation we will do using this, likewise this algorithm will work. So in the distribution model based clustering method, the data is divided based on the probability of how a data set belongs to a particular distribution. Okay, so you just see this image here. In this image, and we can see the inner circle and the outer circle, and the outermost circle. So how much it will cover, according to that it is covering as the inner circle, and that circle circumference, also the next outer circle, and another outermost circle. So this is how we can have the effective distribution model, it based on the clustering, that is expectation maximization algorithms. Okay, and the EM algorithm, expectation maximization algorithm, as discussed in the previous slide, it is algorithm. It is an iterative optimization method that combines different unsupervised machine learning algorithm to find maximum likelihood or maximum posterior estimates of parameters in statistical models that involve unobserved latent variable. Okay, so the main thing is what iterative, it is a type of iterative optimization. So it will repetitive process, it will make iterative optimization method, and it is used to different combine. What it will do, it will different unsupervised machine learning, and it involve the unobserved latent variable. So this is the main concept behind the expectation maximization algorithm. And coming to this EM algorithm is commonly used for latent variable models and can handle missing data. So especially for handling missing data, obviously in machine learning we will go through the EM algorithm, and it consists of an estimation step, E step, and maximization step, that is M step, forming an iterative process to improve the model fit. That is, we will have the E step first, after that M step. So if the E step is not satisfied, and it will move to the M step, and the M step is not satisfied, that is the expected outcome is not reached, again it will come to the E step, and again it will make the distribution, and it will go to the M step. So likewise the iterative process, how the iterative process, for example the iteration 40%, 60%, or 50-50, or 30-70, likewise it will have the ratio of iteration, and will make possible outcome as very good. Okay, and used to handle situations where variables are partially observable. So this is how the EM algorithms works. And here I have given the reference link. You can go through this link and you can have the detailed algorithm explanation. Also the algorithm is written using the languages, that is like Python or R language. So you can very well understand the algorithm theoretical concept here, and you implement using the coding with the help of this website. Okay, thank you for your passion listening.